Potential and kinetic energy test. Number 1. Kinetic energy is A. Stored energy, B. Energy of motion, C. Heat energy. Number 2. Potential energy is A. Stored energy, B. Energy of motion, C. Heat energy. Classify the following statements as either potential or kinetic energy. Use a P for potential and a K for kinetic. Number 3, a car driving at 60 miles per hour. Number 4, the wind blowing through the tree branches. 5, a runner at the starting line of a race. 6, a soccer ball being kicked. 7, a cat sleeping. 8, a ball at the top of a hill ready to roll down. Number 9, a swimmer doing the backstroke. Number 10, a bow with an arrow pulled back. Classify the following statements as either potential or kinetic energy. Use a P for potential and a K for kinetic. Number 11, a rubber ball reaches the highest point in its bounce from one place to another. Number 12, a dart is released from a hand and travels towards the target. Number 13, a race car is moving at its greatest speed around the final turn. Number 14, a football has reached its highest point after being kicked towards the other team. Number 15, a rubber band that has been pulled back but not been let go. Number 16, a water balloon is just about to be let go off a roof onto an unsuspecting friend. 17, a rocket taking off from Earth at nearly 25,000 miles per hour. Circle the answer choice that best completes the sentence. Number 18. One way that potential and kinetic energy are similar is that A, one is moving and the other is not. B, one is involved with water and the other is not. C, they are both involved in everyday life. D, they both store energy. Number 19. One way that potential energy is different than kinetic is A, potential energy is the energy of moving things and kinetic energy is not moving. B, potential is stored energy and kinetic is not stored. C, potential energy is slow and kinetic is fast. D, there are no differences. Use the picture below to answer questions 20 and 21. Number 20. At what point would the roller coaster have the most potential and the least kinetic energy? A, point W, B point X, C point Y, D point Z. 21. At what point would the roller coaster have the most kinetic and the least potential energy? A, point W, B, point X, C, point Y, D, point Z. Use the diagram below to answer questions 22 and 23. Question number 22. At which point, or points, does the swing have the most potential and least kinetic energy? Answer choice A, 1 and 2. B, 2 and 3. C, only 2. D, 1 and 4. Number 23. At which point or points does the swing have the most kinetic and least potential energy? A, 1 and 2. B, 2 and 4. C, only 2. D, 1 and 4. Number 24. Students conducted an experiment by stretching the same rubber band to various lengths, releasing it, and measuring how far it traveled. Length rubber band was stretched in centimeters, 10 centimeters. Distance traveled, 50 centimeters. Length rubber band was stretched, 25 centimeters. Distance it traveled, 80 centimeters. Length the rubber band was stretched, 50 centimeters. Distance traveled, 120 centimeters. Based on the chart, what conclusion can be drawn? A, the more mass that a rubber band has, the more difficult it is to move. Choice B, the shorter the length of a rubber band, the less energy can be stored in it. C, the more potential energy put into a rubber band, the more kinetic energy is released. Choice D, the farther a rubber band travels, the less it can be stretched later. A bicycle rider is traveling up a hill. When the rider reaches the top of the hill, she stops to rest. Then she travels down the hill. The diagram shows the rider in 3 different positions. Which of these correctly describes the potential energy and the kinetic energy of the bicycle rider? Answer choice A. When the rider is at the top of the hill, her potential energy is the greatest and her kinetic energy is the least. B. As the rider moves up the hill, her kinetic energy increases and her potential energy decreases. C. When the rider goes down the hill, her potential energy increases and her kinetic energy decreases. D. As the rider reaches the bottom of the hill, her kinetic energy and her potential energy decrease. Extra credit. What is the name of the pneumonia-like virus that is sweeping across China?